This video covers the nomenclature of esters. The material can also be found in section 17.1 of your textbook. Esters are functional groups that have an OR group attached to a carbonyl carbon. So here's the carbonyl carbon. An OR group is attached to that on one side and a carbon on the other side. So it looks a lot like a carboxylic acid, but instead of an OH in this position, there's an O and then some carbon-containing group attached. We'll refer to this group as the R' group, so the OR' group. To name esters, we're first going to name the R' group that's attached to the oxygen. And then we'll follow the name of this up with the parent name. The parent is the rest of the molecule. In this case, this group is named as though it were a substituent. So it's a substituent coming off of the oxygen. It's a 2-carbon chain, so it's named ethyl. The parent name is named based on the number of carbons in the chain. This is a 4-carbon chain, which would be butane if we're thinking of the alkane name of a 4-carbon chain. We will drop the E ending of the alkane name and replace it with O8. So because there's an ester on the end of this 4-carbon chain, it's a butanoate. Let's look at a couple of additional examples. Again, we're going to name the R' group first as a substituent, in this case a benzene ring directly attached to the oxygen without a CH2 spacer is called a phenyl, not a benzyl. So phenyl comes out front. Then the parent chain is named. This is a 5-carbon chain. So pentane would be the alkane name. We drop the E of pentane and add O8 to designate that there's an ester in this molecule. With this next example, there's a substituent off of the parent chain, so we have to deal with that as well. We're still going to name the R' group first, followed by a space, and then any substituent attached to the parent. So the R' group is 3 carbons in length, or a propyl. The parent chain is 4 carbons in length, so a butane, where the E is dropped and O8 takes its place. On this 4-carbon chain is a bromo substituent at position 3, and that portion of the name comes as a prefix directly before the parent name, not before the R' group. Take a moment to try to name these two esters. When you think you've got the names of both, continue playing the video to check your answer. In this first example, although the R' group is longer in length than the parent chain, we still treat it as though it is a substituent. This is 7 carbons in length, so we call it a heptyl. The parent chain is only 6 carbons in length, which would have the name hexane if it were an alkane. It becomes hexanoate now that it's an ester. We count the hexanoate chain from the ester carbon to the substituents. In this case, there's 2 methyl groups at the 5 position, and we put the names of those directly out front of hexanoate, so 5,5-dimethyl. On this bottom example, the R' group, shown in red on this side, is a benzyl group. There's a CH2 spacer between the oxygen and the aromatic ring, so we refer to this as a benzyl. The parent chain is only 2 carbons in length, an ethane. We drop the E of ethane, replace it with O8, and off of carbon 2 of that ethanoate chain, there's a chloro. So benzyl 2-chloroethanoate. When an ester has both its carbonyl carbon and the oxygen embedded within a ring, it is referred to as a lactone. The way that lactones are named is by naming the parent cycloalkane. So this is 5 carbons in length. so a cyclopentane, replacing the E ending of cyclopentane with an one ending. So a cyclopentanone. That one is referring to the carbonyl oxygen. Additionally, a 2-oxa is placed before the parent name. So before the cyclopentanone, we place 2-oxa. That 2 is referring to the oxygen of the ester. So when we count lactones, we count from the carbonyl carbon to the oxygen and then further around the ring. If there are substituents on a lactone, those substituents' names are placed as prefixes before the parent. In this case, there's a chloro at position 4 when we count from the carbonyl carbon to the oxygen and further around the ring. So 4-chloro, 2-oxa, cyclopentanone. In this third example, the ring is 1 atom larger in size, so it's a cyclohexanone rather than a cyclopentanone as in the other cases. We again count from the carbonyl carbon to the ester oxygen and further around the ring to substituents. Additional substituents names are placed out front. So this is an ethyl group at the 4 position. The 2-oxa is referring to the ester oxygen within the ring, and the one is referring to the carbonyl.